Today we're going to learn how to work with arithmetic sequences and find specific terms within that sequence. We have two different examples here that we're going to be working with. The first one is just a list of numbers or a sequence of numbers, and we'll need to find the pattern. The second one, we're given the pattern in equation form, and then we can find the terms from that equation. So on this first one, we're asked to find the 7th and the 100th term in the sequence. Now a sequence, again, is just a list of numbers with a specific pattern. So if we look at this pattern, going from term to term, say from 5 to 12, we are adding 7. And then if we go from 12 to 19, same thing. And then from 19 to 26, the exact same thing. We're adding 7 every time. So if I were to list out these terms, we already have 4. So to get to the 7th term, we don't need to go much further. So if we add 7 again, we're going to be at 33. If we add 7 again, we're going to be at 40. Then add 7 one more time, we're at 47. So not too hard to find the 7th term if we just add that common difference multiple times. Now, I don't necessarily want to do that if I have to go all the way to the 100th term. But if we think about what we just did on this last one, we started with our 5, and then we added a common difference of 7. But how many times did we do that? Well, to get out to the 7th term, we needed to add it 6 more times. So if I simplify this out, I end up getting 5 plus 42, which happens to be 47. So 47 becomes our 7th term, which I'm going to denote with this A7. Now, to get to the 100th term, I, again, don't want to go this route of just adding 7 99 times to get out to the 100th term. So I want to do it the shorthand way and say the 100th term is going to equal the first term of 5 plus 99 more terms of the common difference of 7. And if I put that in the calculator, 5 plus 99 times 7 ends up giving me 698. So then the 100th term is 698 on this first sequence. Well, let's go to the second example here and try to find the 7th and the 100th term. Now the nice thing about a sequence defined as an equation like this is if I just want to find the 7th term, I'm going to let n equal 7 and plug that into the equation. So 1/4 times 7 plus 5. And then I just evaluate. So if I take 1/4 of 7 and add 5, I end up getting 6.75. So my 7th term is 6 3/4. Or if I want to find the 100th term, a 100 is going to equal 1/4 of 100, and then add the 5 on that was in the equation. So 1/4 of 100 is 25. Add the other 5 in, we end up getting 30. So then the 7th term we found was 6.75. The 100th term is 30. So sequences can be defined multiple ways. The first way, we had just a list of numbers with a pattern. We found that pattern and then either added that 7 over and over again, or we recognized how many more 7s we needed and then used multiplication to help us quickly add those 7s onto that initial 5. Or the second method we had an equation representing the sequence. So if we wanted the 7th term, we just plugged in a number 7 and got our value for that 7th term. Or if we wanted the 100th term, we plugged in 100 to get the value of the 100th term.